Hello everyone, my name is Jijing Chen. Today I'm going to presenting our project of development and testing of a ground control station for multi-UAV operations using NASA's Warwing API. This is presenting by California State Polytechnic University, Pomona. Overview of this presentation, we will go over research objective and motivation, UAV mission, design process, simulation environment, UAVs and hardware, flight test, finally conclusion and future work. The research objective of this project is, since nowadays the operation with multiple UAVs are very frequent, and it's very necessary to implement a single one ground control station for multiple UAVs. So our goal is to develop one ground control station for the operation of multiple UAV for various missions, including our flight detection and suppression mission in this project. And our ground control station will display vehicle information and also include a simulation environment. We are using NASA Warwing API, which is used for visualization of 3D globe map and geographic information. Here is showing a UAV mission we use in this project. This project is for fire detection and suppression mission. So as you see on this diagram, we have two zones, which is one for fire detection zone, another one is for fire suppression zone. First, the fire detection zone will fly out automatically and then record to search for fire. Once it finds the fire, and it will record its location and then send back the location to the ground control station. Once the ground control station receives the fire location, and it will send the fire location to the suppression zone. The suppression zone will fire to that location autonomously and then drop the fire suppression to extinguish the fire. After that, it will return to home as well. And here is the communication between the UAV and the ground control station. And they both using the SB radio for communication. As you see from on this diagram, detection zone and suppression zone are embedded or carrying the SB radio. And then they will communicate with their location information and other information with the ground control station. And we're using NASA Warwing API. A NASA Warwing API is an open source high-performance 3D virtual globe API that comes with an SDK. And it also provides a geographic rendering engine and a huge collection of the high-resolution imagery and terrain data for NASA servers. And here is a design of our ground control station interface. What you're seeing here is the display UAV data in real time. Here is the icon of the UAV location in real time, and here's the path of showing where the drone had been through. On the left-hand side is the control panel of the UAV. We can connect and disconnect the SB data with the ground control station. Once we establish a connection using the SB radio, then we can add as many drones as we needed on the ground control station. The ICAO number is the ID of the UAV. And then you can select that if the drone is a fire detection drone or suppression drone. If it's a fire detection drone, it will show as a red icon with the drone. If it's suppression drone, it will show a yellow icon. Then we can connect each drone individually. We had an option to show the path or hide the path as needed. Another function of our ground control station is a simulation of the trajectory. So since it's a fire detection mission, so we will need to search for the fire. There's different type of trajectory that can be generated from the our trajectory generation algorithm. So our simulation is to test all those different algorithms. So one type of the trajectory is the remover path, and the path can be searched for the area evenly, and it will, as we say previously, and we will take into the trajectory generation algorithm that is take into account as the speed and the altitude of the UAV, as well as the radius of the search area. The output of the algorithm is a set of waypoints that UAVs will traverse. And here is the image of a set of waypoints. And the set of waypoints we will set into our simulation, and our GCS simulation will simulate the path along with all those waypoints. Another type of trajectory is polyline path, and it just takes into one waypoint individually and then perform straight line from one waypoint to another waypoint. The two test vehicles we're using in this project is DJI-S1000 optocopter. The maximum payload of is approximately 11 pounds, and each of them had a 18-inch propeller. Both vehicles included a pistol autopilot, SB radio, and other accessories. Here is the hardware setup for each vehicle. And first, we will have the pistol flight controller, which had a built-in IMU and a GPS. And then we had the SB radio model, had a range of a mythical mile and data rate up to 200 kbps. And then we had the onboard Raspberry Pi mini computer with a 4 GB RAM, 1.4 GHz processing speed, and 2 GB data storage. And for the search for the detection drone, we will have the IR camera on board, and then for the rescue drone, we will have a payload mechanism for the suppression. And we had 3 test cases in this project. All the test case purpose is to test the ground control system and UAV communication using the SB module. There are 3 types of testing. One is the ground test for both UAV to ensure that the communication can establish before we do the flight test. And then we will establish the flight test one by one. First with one UAV, then we will have 2 UAV. Here is the ground test for 2 drones. Is performed in Cal Poly Pomona lab, UAV lab, that our team member will carry both drones, walk around on the lab, and then we will see that if the icon will show up on the ground control station, and if the ground control station record the path. As you see on the left-hand side, the one computer is work as a ground control station. Another computer is just a monitoring of the data sending from both drones. And here is the drone we're using. As you see on the right-hand side picture on our user interface of a ground control station, that we can see both icon of the drone and also 2 paths, which indicate that the ground test is successful. The next test we're doing is a flight test with 1 vehicle. That we are doing it at the Cal Poly Pomona farm, which is open area that we can fly our drone safely. And here you see that is our drone with our ground control station with 1 UAV. And you see that it's moving, which is flying. And then you can also see the purple path indicated where the drone had been go through. The next flight test is with 2 vehicles. And here show the process of how we connect for each vehicle. First, we will connect the SB, and then we will select a new vehicle. Once we establish the connection, the icon show up. And then right now we establish a connection with the next drone. We select the different type of drone, which is one is a detection drone, one is a suppression drone. And then after that the drone take off, and we will see the drone is moving. And then we will click the Show Path button to see the path of the drone. And from this video indicate that our flight test with 2 vehicles is successful. Conclusion of this project. The ground control station had been successfully developed to communicate and control multiple UAV from a single ground control station. And we are using NASA Woven Java API for user interface, and then the SB radio for communication between ground control station and UAV. Demonstrating by the flight test, the ground control station is capable of receiving the message coming from the UAV and displaying multiple UAVs location on the map. In addition, the ground control station incorporated a simulation environment to test the UAV trajectory generation algorithm. The future work of our project will involve adding additional feature to the ground control station. This is including a display more information about the UAV, such as the battery life, ability for the ground control station to sending control command to the UAV. For example, when the battery is low, the ground control station must send a command to the UAV, instructing the UAV to return to the launch state. Our ground replanning for our ground calculation will also able to display a 2D or 3D map of the scan area that are obtained by the stitching the image collecting by the camera on board of the search UAV.